edition of 3D Printing News Unpeeled. So today we're going to be looking at some news that's happening. Uh, and the first news item is with Desktop Metal. So Desktop Metal had a $9 million US dollar order from a major German automaker. This is a second order from the same automaker, and it totals $16 million from that one automaker for Desktop Metal. That's a considerable order, especially given Desktop Metal's revenue. What's even more interesting, I think, is that the company is reporting that it's going to be used to mass produce powertrain components. Now, if we're unpicking this, it says that it's a German automotive manufacturer. We don't know, or implying that's a German automotive company. So we don't know who it is yet, and we may never find out, or it may take us a long time to find out. So, given the X1 portfolio, given the fact that that it's specified that it's binder jet, I still think it's most likely to be an S1 kind of S Max or other kind of sand casting machine. I think that would be the most ripe for industrialization, most ripe for this kind of level of investment for car components at the moment. Now, this is a guess, to be honest. I would really think that would make sense for car companies to look at optimizing sand printing by these S-Max models for casting of molds and cores. That much more likely than metal, given Desktop Metal's portfolio. Now, the company said transmission components or drivetrain components. The part to me that makes the most sense would be a transmission case or a drive housing, and then using that sand casting to get that. So generally, we don't know this; it's a guess, but it's great news. So this moves us a step closer to industrializing for 3D printing. Now, who is it? Right? Could it be Stellantis subsidiary Opel, Ford Europe, BMW, Volkswagen? Most people seem to point out that it's either BMW because they invested, or Volkswagen because they are kind of ahead of the game. It could also be the outside guess, Daimler or Mercedes-Benz. I think it may be more likely to be kind of like a Opel or Ford Europe kind of subsidiary trying to like leapfrog the other ones through this technology. But most people seem to think it's BMW. Now, drivetrain transmission components, very interesting. We could be looking at a lightweighting kind of thing. Probably it's going to be casting. I'm pretty sure it's a casting, sand casting type of implementation where they're looking at cost savings versus traditional kind of investment casting or alternatives. It would be very exciting if it was an e-drive or an electrical vehicle kind of component, because that would mean that they're using car companies are using this electrification as a way to industrialize additive manufacturing on the side. Things like cooling channels would be exciting, but this would probably not be the technology for it. It would be very notable if there's a rotor or some kind of other critical kind of part. Probably it's going to be. I'm guessing it's an X1 printer sand casting project with casings, with optimized topology, optimized kind of transmission casing. I think that would be the most likely thing at the moment, like the machine you see in front of you. So yeah. That's good news. I think it's good news for 3D printing that car companies are taking interest, they're investing in the technology, and they're moving to production. So we would expect a lot more announcements like this. The next news is that Julia Corner and Ruth E. Carter have collaborated on the Wakanda Forever costumes once again. The team was part of the group that got an Academy Award nomination for the original Black Panther movie for their costumes, and they used 3D printing then. And the team have now come back and have used more 3D printing for the Black Panther Wakanda Forever movie. In front of us, we can see the props that have been made using 3D printing. And then Queen Ramonda is in front of you, and the crown and kind of neck piece that she's wearing is some of the 3D printing components. Those are the ones that we've talked about. What is probably not, well, 1, 2, 3, completely apparent and initially is the fact that rather than stereolithography or vat polymerization, which has been used by the props guys extensively because it's really detailed and easy to paint, this time the team says they used selective laser sintering or vat polymerization, or not vat polymerization, but powder bed fusion to make the parts, which would require a lot more painting. But I think, if you look at the components in front of you, these jewelry pieces and stuff, yeah, that would be kind of the scale that would make sense maybe from a cost perspective to use powder bed fusion plus a couple of layers of paint rather than about polymerization. It might be a little bit more detailed and smoother, easier to paint initially, but might be cost effective and more brittle. I guess, also she has to wear this on screen. She's got to move around a lot. I think maybe powder bed fusion would be a bit more easy. You can electroplate it as well. I could do the other stuff as well. But hey, I like this. I like this a lot. We often know that 3D printing is being used extensively in stop motion animation, in props. Think of like I'm making a space laser. It's just a one-off thing. It needs to be specific. It's a brilliant business case for 3D printing. There's a lot of 3D scanning being used, a lot of models for effects as well. So to have people talk about this, we have to stop and really remember that there's a lot going on in the film industry and a lot of really exciting things are happening that they often don't really talk about, because maybe even the director may not even know that 3D printing is happening in this case. It's just, they want a magical thing to appear, and we're the technology that makes that happen. The next news is by Tanya Meisel, plus a whole bunch of other people working at Fraunhofer IPMS, the Brandenburg University of Technology at Cottbus, and Bosch, which caught my eye. And they are working on directivity optimization of MEMS ultrasonic transducers by implementing acoustic horns. So MEMS, again, these mechanical electrical components that do all sorts of cool things, like make the accelerometers on our phones. So I've been writing a couple times about 3D printing used for MEMS. I think this is a huge area of potential growth. MEMS are small devices that have to do certain tasks in combination across different domains very, very well. If they do this, and if they're also low cost, they get produced in the millions or hundreds or even billions of times, right? So this to us is a huge chance, right? 3D printing is always struggling for mass adoption. MEMS could, at least if it works in MEMS, we could just get propelled into the millions or tens of millions of components one time. Now, what are the team doing? They're looking at these acoustic horns, right? And for a MEMS, right? And they've designed it using FEM or finite element analysis. And they're optimizing this acoustic horn for 3D printing. Now, what they're trying to do is get the directivity pattern of the MEMS-based ultrasonic transducer to essentially, improve it, which means that they have to focus sound better. Now, what they're saying is they can do this with 3D printing. And what's more is they can then get a better directivity pattern, or a better pattern corresponding to the task at hand, using 3D printing. And they say they're using a conventional 3D printing technique, which means that the cost of this component is inexpensive. Now, I love this because, on the one hand, again, this could mean, if this works, this could mean a huge industrialization into the hundreds of thousands or millions of sensors. It uses 3D printing to its advantage of being able to make custom geometry. But also, this is a potentially high volume application because of that custom geometry. And what I love about this is that they're saying in the paper, I tried to find the 3D printing technology they use, and they don't mention it. And that to me means that some people are working on some patents or some very secret type stuff to try to figure it out. I'll read the paper again to see if I can find some allusion to the technology. But the fact to me that they're talking about this MEMS device using 3D printing and they don't mention the technology, not even broadly, to me means that this is a real industrial application rather than some fun little research project people are doing. And what are they doing with these MEMS horns? We really don't know. It could be some kind of speakery type thing, or it could be something very cutting edge, like rather than acoustics, it's a horn for energy harvesting, for example. So, that's the kind of stuff that they're working on. And I love to follow this kind of work very closely because it'd be super exciting. All right. Thank you very much for your time. My name is Joris Peels, and this is another edition of